In this video, we look at another application, this one involving lemon pies. A store is selling lemons for 65 cents each. Each lemon yields approximately 2 tablespoons of lemon juice. How much will it cost to buy enough lemons to make 3 9-inch lemon meringue pies, each requiring a half a cup of lemon juice? Side note, there are 16 tablespoons in 1 cup. There's a lot of information going on in this problem. So the very first thing that I want to do is I want to gather what I know. Sentence 1 says a store is selling lemons for 65 cents each. That means I have a relationship or a rate going on. I know that 1 lemon is equivalent to 65 cents, or in other words, I have a relationship between 1 lemon and 65 cents. So I'll write that relationship down. The second sentence tells me that each lemon yields approximately 2 tablespoons of lemon juice. That creates another relationship or another ratio. So that means 1 lemon is equivalent or corresponds to 2 tablespoons of lemon juice. So far, so good. The third thing says, how much will it cost to buy enough lemons to make 3 9-inch lemon meringue pies? This is what I'm trying to find. I am searching for a cost, specifically the cost for 3 9-inch lemon meringue pies. I'm going to file that and keep that handy. That's what I'm looking for. What else do I know? Well, I know that each pie requires half a cup of lemon juice. That gives me another relationship I can look to. 1 pie has a correspondence to half a cup, or if I like, 0.5 cups of juice. And then finally, I have a note that there are 16 tablespoons in 1 cup. So I could write down 1 cup is 16 tablespoons. I have 4 ratios that I can work with. I have a task, which is to find the cost on 3 9-inch lemon meringue pies, and I think I'm ready to start the problem. Everyone might solve this problem a little differently, but judging from the information I have, I see a lot of ratios or rates. And that signifies to me, dimensional analysis might be a good tool that I could use to solve this problem. The question is, where do I begin? Well, I think I'm going to start with what I'm trying to find, which is the cost of 3 9-inch lemon meringue pies. Specifically, I am starting with 3 pies that I have to make, and I think that's going to be my focal point to begin with. I have 3 pies. Now, what can I do with pies? Well, I need to cancel out the pie units, and I need to eventually end up with units at the end of cost. Do we see one of these relationships or ratios that will help me get rid of the units of pies? I think the first one right here will do the trick. 1 pie is 0.5 cups of juice. So how about I set this up with 1 pie here and 0.5 cups of juice here in the numerator. Why did I do that? Because remember, when we set up dimensional analysis, or when we multiply by unit fractions, we want the units to cancel in the numerator and the denominator. So far, so good. Now I need a relationship between cups and something else. So why don't I do the next guy? This one has cups in it. So let's use this relationship to get rid of cups. I know that 1 cup is 16 tablespoons. Again, why was it important to put the cup in the denominator, even though it shows up in the numerator in my relationship? That's because I wanted the cups in the numerator to cancel with the cup in the denominator. Okay, carrying on. Do you see the idea? Do you see the pattern? The next step is we have to get rid of tablespoons, right? We're ultimately working our way to cost. Well, let's see. I have a relationship or a ratio involving tablespoons, and it's this one right here. It says that 2 tablespoons of juice corresponds to 1 lemon. So when I set this up, I want to make sure tablespoons are on the bottom. So I have 2 tablespoons corresponding to 1 lemon. This allows my tablespoons to cancel from numerator and denominator. And I have one final conversion I have to make. Namely, lemon has to be removed because, again, I'm looking for cost. And I think this last ratio or this last relationship is going to do the trick. Let's multiply now by the ratio of 1 lemon to 65 cents. Doing so will allow us to cancel the lemon in the numerator with the lemon unit in the denominator. So what do we have? Let's put it all together. When we multiply these fractions, in the numerator we have 3 times 0.5 times 16 times 1 times times 0.65. And that's a cost, right? And in the denominator, I have 1 times 1 times 1 times 2 times 1, which is just 2. Now, my brain tells me when I have fractions, I like to cancel like factors, so I might just do this. I must just take this 2 and cancel that with the 16 in the numerator. And now I'll pull out my calculator. I will take 3 times 0.5 times 8 times 65 cents. When I multiply all of those numbers together, I get 7.8 in the numerator with the unit dollars and 1 in the denominator. 7.8 divided by 1 is just 7.8, but this is money, so I want to rewrite it as a numeric dollar value, which would be $7.80. To make 3 9-inch lemon meringue pies, it will cost us $7.80, given all the information that we're given. This was a long and complicated problem with a lot of information. Now, if you solved it and came up with the same answer but used a different technique, that is perfectly fine. In fact, that's great. But for those of you that might want to use one of the tools we've discussed in class, I think that dimensional analysis works really well with this type of a problem. Good luck as you're working your homework, and if you have any questions, don't hesitate to reach out and contact me.